I'm starting this lesson out actually from a web browser. So here I Googled coronavirus stats and I got this little graph for New York. And if I scroll down the page a little bit here on this web browser, I can get some more statistics for our county. So I'm actually interested in kind of comparing Ulster County versus the rest of the state. So I'm going to take some of this information and actually put it in a two-way table. So the information I'm going to use the data for New York and the data for Ulster County. So the two things I have, if I make this table, and I use my normal, 4x4 just because that's the amount of information I have. I have Ulster and not Ulster. And I have died and we'll say not died, but then that's kind of weird wording. So from here, we're going to start to fill in what we know. So I know the total confirmed cases. I should really write here on Ulster, like confirmed cases in Ulster County, but we don't have a whole lot of room, is 1,416. Okay. I know the people that have died in Ulster is currently 31. The total confirmed cases for the whole state. So the whole state is Ulster and not Ulster together. So that's going to go in my final total is 327,000. So this number is going down here. And then the total deaths is 20,828. So this is typically how you would gather data. You'd find some sort of information online or, maybe you did your own study. So looking here, I'm going to start to fill in that extra information. Now I already have the numbers written out because these are not simple subtraction questions. So here, if I subtract 1,416 minus 31, I get 1,385. Here I would have 325,584. Here I would have 306,172. This one would be 20,797. And then my one that checks in both directions is 304,787. So ultimately what I was interested in is I wanted to compare Ulster County to kind of what's going on in the state. And this brings in a probability topic called independence. So the first thing I'm going to find out is the probability that someone died given they live in Ulster. And this is even a little more complex because it's also given that they've been diagnosed with the coronavirus. So really, of the people that have been diagnosed, what percentage died? So this is, if I look, my given is Ulster, right? So I'm in this section. So that's going to be 31 out of 1,416. So looking at this, if I actually typed that in my calculator, that comes out to be about 2%. I'm going to get the actual number. So that actual number is 0.022, a little over 2%. So I want to compare that to what's happening in the whole state. So I'm now going to just find the probability that someone's died in New York State without any other givens. So probability that someone died is this number, right, out of the total number of people. So that's 20,828 over 327,000. So I'm going to find that answer now. And that answer is 0.064 approximately, so about 6.4%. So when we start to talk about independence, if these two events were independent, these two answers would have been exactly the same, okay? So right now it looks like people in Ulster have less of a chance of dying from the coronavirus So something about Ulster is impacting this probability of dying. Okay. Now, obviously, there's a million things you could go into. I mean, maybe people in Ulster that are getting sick have less comorbidities or other problems, or maybe we're just earlier in the disease progression than some parts of our state. So people are further ahead. So there's no way from this study that we can say what is causing this. Okay. But we're seeing that Ulster and died from the coronavirus, okay, are not independent. If they were independent, if living in Ulster had no impact on this number compared to all of New York State, these two numbers would be exactly the same. They would be equal. Okay, so Ulster and dying, we would say, are dependent events. So something about living in Ulster is giving a different percentage of people that have died from the whole state. Okay, so basically, to kind of extend that further, or what we're going to check, if two events are independent, the probability of, we're going to call this A and B. Okay, so if we're saying dying is event A, if I put an A here instead of writing the word died and put a B here instead of putting the word Ulster, basically the probability of A given B would be the same exact thing. So New York State would have the same exact number as the people that died in just Ulster County. So that would equal the probability of A. So we're going to see that in our Delta math problems. Once again, these numbers are going to change. It's not the full story. We don't even know if the numbers were reported completely correctly, but that's the idea of independence. This will be true if two events are independent. If these come out as different numbers, we would say the events are dependent, or the one event impacts the probability of the other event, right? You're dependent on someone, right? They have some sort of impact on you. You're independent. People don't impact you. Those probabilities stay the same. So here's our first Delta math example. It says a group of students at a high school took a standardized test. The number of students who passed or failed the exam is broken down by gender in the following table. Determine whether gender, so here's our one thing, and passing the test are independent by filling out the blanks in the sentence below. So first off, just like any table, we'll fill out our totals. So this is a 10, 28, 42, and we have a 50 here. So the totals are 60. So they're actually going to guide you through this. And one other thing that I haven't really done a lot with notation, because you guys have been at home and that's like a whole nother layer of probability. When you have this line stands for given. Okay, so when you see that line, it means given. So the two probabilities that they're going to compare, they're going to find out what is the probability that you're male given that we know you failed. So in our other example, that looked like, what is the probability that you died given that you live in Ulster County? Okay, so that's that first piece. And then we're going to find the probability that of overall that people are male, or the probability overall that people died in New York State. So our first given is fail. So we're here, okay, and we're finding the probability of male. So this is 4 out of 10. And here we're going to the nearest thousandth. So basically we're just going to type that in, get the nearest thousandth. We don't really need the thousands place. You can just type in 0.4. Probability of male. So now we're going to just look at the males out of everyone. So that's 28 out of 60. So 28 out of 60, if I type that in my calculator, is also 0.4. So just to make sure we're clear, this one came from 4 out of 10. I just kind of did that in my head that was 0.4. So looking at this, these two events are equal. So in this pull down menu, you would just choose equal. So because they're equal, whether or not someone's male didn't really impact the chance that they'd fail, right? They both came out the same. So those events are not impacting each other. So we would say that they're independent. Okay, so those would be the answers to the first part. So let's move down to the question at the bottom of the page. This one is the same situation, right? We have gender, we have passed and failed. So we'll fill in that table, and I know these are a little harder to figure out, so I'm just going to write in the answers. So this is 93, 145, we have a 238. I figure you guys are fine with these, so you can just copy them down. You don't have to worry about subtracting and adding yourself. And here's my totals. So we are trying to see if gender and passing the test are independent by filling out the table below. If we were in school, you'd have to kind of decide what you were going to do here and here, okay? So for this one, the one they picked for us, what's the probability that someone fails given that they're female? And what's the probability in general for everyone if they fail? So fail given female, we are in this section, correct? So this is 133. Those are, I'm sorry, we're doing failed, so not that one. 12 out of 145. So we have 12 out of 145, which to the nearest thousandth equals 0.083. The probability that someone fails, just out of everyone, so my total fail number is here out of the overall total, so that's 74 out of 238, which is 0.311 if we were going to find that as the final answer. So I see that these two results are definitely unequal. It looks like the females in this case have a much smaller probability of failing than the general population. It could be smaller or bigger, just like we saw at Ulster County. The people that had coronavirus had less of a chance of dying versus the general New York population. So we would say that these two are dependent events. Now, moving on to the next page, we're going to have another way to test for independence. So I'm actually going to look at these up here. One thing I want you to notice is that when we did these probabilities, we were always kind of working in the same locations in the table. So we had 4 to 10 and 28 to 60. So see how they're kind of located in that same row, like 4 over 10 and 28 to 60. And at the bottom of the page, it was kind of the same deal, except we were going in the other direction. So we had 12 out of 145 and 74 out of 238. So that gives us a certain type of symmetry in the table that's going to help us do the next problems.